Okay, I'm back. So real quick, I wanted to show you how you're going to complete this corn genetics and chi-square analysis. Be sure and read the introduction just to give you some background information. You're looking at 4 different crosses. Monohybrid cross 1, monohybrid means a single trait. Monohybrid cross 2, dihybrid cross 1, and then there's a dihybrid cross 2. And you're given data. So the first thing you need to do is look at that data and see what the ratio is. And then from your ratio, you'll get your expected. So let's start with the data. We've got 222 purple seeds and 78 yellow seeds. So the first thing I want you to do is remember the 4 ratios that I told you, because they're going to apply here. You're going to need the 3-to-1 ratio, the 1-to-1 ratio for the monohybrid crosses, 9 to 3 to 3 to 1, or 1 to 1 to 1 to 1. All 4 of these are going to use these ratios. In other words, I'm looking at this right here. Is this ratio 3-to-1 or 1-to-1? Well, clearly 78 and 222 are not the same, so it's not 1-to-1. It's closer to a 3-to-1 ratio. The way you can see what the exact ratio is to take the big number, 222, and divide by the small number, 78, and that gives you 2.846. I know you can't see that, but there you go, 2.846 to 1. So that's close to a 3-to-1 ratio. Now what a chi-square analysis does is allow us to see if it's close enough. If it's close enough for us to say, okay, this is a 3-to-1 ratio, that means if this is a 3-to-1 ratio, then my parent cross is heterozygous for both parents. So that's kind of my null hypothesis. My null hypothesis is that this 3-to-1 ratio says that the parents are big A little a crossed with big A little a, and you can use whatever letter you want. And that any variation in that is just due to chance in the number that I counted. So we need to figure out our expected. The first thing you do when you figure out your expected is to get the total of your observed. So if we add those together, that's going to be 300. I've got 300 kernels total. So if I've got 300 kernels and my expected is a 3-to-1 ratio, how many should be purple? Well, 3-to-1, that means 75% should be purple and 25% should be yellow. So I would take my 300 in the calculator and I would multiply that by 0.75. And that tells me that 225 should be purple, and then the rest should be yellow, which is 75. So that's going to be my expected data, 225 and 75. And I'm going to compare that to 222 and 78. And then you just do your chi-square analysis. Remember that your chi-square analysis is the sum of your observed minus the expected squared over the expected. So my observed is 222 and 78, purple and yellow. That's the observed. The expected is what I got based on my ratio, 225 and 75. So I'm going to subtract those two. That's 3 squared is 9. So I'm going to say 9 divided by my expected is 225. And then go from there. If you look in your assignment, you've got a critical value table there that you can use to compare and answer questions. So hopefully that at least helps you get started. You're going to do the same thing on all 4, but you're using the 2-trait probabilities here. So just try it. It's math. Even if you don't quite get the genetics part yet, you will. I'm including some genetics problems that I'm going to have you start working, and as you work through more genetics problems, you'll start to see these ratios popping up. All right, that's it.